Hi, Mr. Simone again from Hamden Middle School. For today's video, it's just going to be a continuation of another video. This is kind of like that part 2. And basically what we're going to do is we're going to take 2 coordinate points and use that information to kind of run through and figure out the other forms of a linear equation or the equation of a line that these 2 points will lie on. We'll start out by finding the slope first and then kind of use that information to go through. Alright, so for this problem, we'll start out by finding the slope. Again, slope is the letter m, which means change in y over change in x. Alright, is that ratio. Sometimes write this as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, the subscripts are just for naming purposes. The negative 5 would be our first x, or x sub 1. Negative 3 would be y sub 1. Over here we have our x sub 2 and y sub 2 because it is our second coordinate point. Plug the information into the equation. We end up with negative 4 minus negative 3 all over 3 minus negative 5. You'll notice what I do here is I make the subtraction sign slightly larger than the negative sign so we can distinguish between the two of them. On the top you're going to end up with negative 4 minus negative 3, which is the same thing as saying negative 1. You can use a calculator if that doesn't make sense to you, or you can use a rule that we do at the middle school. Some teachers teach it as add the opposite or keep, change, change. You can change these values to plus, negative. You can change any subtraction problem to an addition problem. If I have 3 minus negative 5, that's going to simplify to 8. And again, using that same idea of keep, change, change, or add the opposite, I end up with 3 plus 5. So what we've done, once we have these 2 points, we do have the slope to kind of help us answer some of the other questions. So a point slope just says that if you're given a particular point, which we're given 2, and the slope, we can represent an equation for it. So for this one, let's do the second point. We'll use this as our particular point. To write the equation, we'll write y minus negative 4, which is our y, equal to the slope, which is negative 1/8, times x minus 3. If you wanted to, some teachers might have you keep this as a negative 4, keep it in parentheses, or you can rewrite it to make it a little bit cleaner. Just y plus 4 equals negative 1/8, and then x minus 3 inside. That's one form. The other form that you could use is using the negative 5, negative 3. If you do that, this is what it would look like. So I'll just write or. This would be y minus negative 3 equal to negative 1/8, which is still the same because that's our slope, times parentheses x minus negative 5, close parentheses. If you want to clean this up a little bit, you could rewrite it as y plus 3 equals negative 1/8, and then x plus 5. Alright, so that's kind of what you can do for the point slope form. If we want to convert this to slope-intercept, we can choose either line, whatever you'd like. Maybe we'll go with the top one. So I'll rewrite this. I'm going to rewrite it in this form though. So the y plus 4 equals negative 1/8, x minus 3. To go through this process, all we need to do is distribute out the value of our slope first. So we'll start by distributing. We'll end up with y plus 4 equals negative 1/8 x plus 1/8 times 3. We can just write that as 3 over 8, positive 3 over 8. If you're questioning where I got the addition sign from, we have a negative slope and we're multiplying it by a negative, or in this case subtract, but you can think of it as a negative value. So negative times negative is positive. Once we get there, we're going to move the 4. So we'll subtract by 4 on both sides, which will leave us with y equals -1/8 x. And now here's the tricky part, is how do we write this value, or how do we subtract out? Okay. Some teachers will actually have you keep the +3/8 and then just write down the -4, but in terms of eighths. So if we do that, we can write this as subtract, and to convert -4 into eighths, we have to multiply 8 by 4 to get that numerator, and the denominator will stay as 8. So we can represent -4 as -32/8. And again, -32/8 is -4. All right. Go through this a little bit more. You end up with y equals -1/8 x. Subtract those values out. We'll end up with, what is it, -29/8. All right. For our slope-intercept form, we have our slope, which is -1/8. Our b, or our y-intercept, is going to be the coordinate point 0, and then comma -29/8. So you can figure that out. Last thing we're going to do is we're going to convert this slope-intercept form into standard form. So I'll rewrite our equation, y equals -1/8 x minus 29/8. To write in standard form, the thing to remember is that a, b, and c have to be whole number integers, and more specifically, the a needs to be positive. So the first step, we're going to subtract, we're going to try and get rid of, we're going to try and get the x value to the other side. So we're going to add by 1/8 x to both sides of our equation. You can do that. You can move that entire quantity. You'll end up with 1/8 x plus y equals -29/8. Now the rule is, again, that a, b, and c have to be our whole number integers. So the only way to get rid of this divide by 8 or by these fractions is to use something that we've done earlier, which is fraction busters. We can multiply both sides of our equation by that denominator to get rid of those fractions. So we'll multiply both sides by 8. You'll end up with, let me just change the marker here. You'll end up with 1x plus 8y equal to -29 as your final answer. All right, so we have our standard form. If 1/8 happened to be negative, you'd have to multiply by a -8. Some kids kind of question that. So that is our standard form. This is our slope-intercept form. And lastly, this is our point-slope form of linear equations. If you were to graph these three different equations, which actually are the same representation, it'd be all the same line. Hopefully my math is right. It's a lot of stuff to kind of convert, but you can keep working at this, and I hope this helped.